Okay, y'all, let's get going. A little quick tap into some ZPP as it pertains to graphs. This is going to be a good one, y'all. Well, hey y'all, how you doing? Welcome back. Not gonna be before you too long. Let's cut the music here. And wanted to talk a little bit about, let's continue our conversation on ZPP, right? Zero product property. Now in the last video, we talked about how to evaluate it. And now we're gonna look at it, explore it a little bit as it pertains to functions. So let's remind ourselves, remember when I gave you something like this? Now we've looked at this, and we'll get back to this in a second. But now if I call it a function like f of x equals this, right? Remember when I used to put this? Or actually, let's go with the f of 4. Let's say if f of 4. What am I saying when I say f of 4? When I say f of 4, right, I'm replacing x with 4, and therefore I'm just evaluating, right? I'm reminding us of something that we did in a unit prior to this. And then you would get 6, and then your answer would be 6. So when f of 4 to this equation, the answer is 6. Remember? And so essentially what we've been doing is saying what happens, right? When we're doing zero product property, we're saying, right, f of x equals 0, or the whole thing, right, equals 0. So we set it equal to 0, and therefore we can discover which values of x would make f of x 0. Well, you should know. Okay, well, without even doing any work, you would say x is 3, and then x is negative 2. So think about this. When x is negative 2, f of x is 0. You with me? When x equals 3, f of x equals 0. Where has there been something where we learned, right, we studied that when the x value equals something and the y value or the output equals 0, that describes something very specific. Again, think about the graph work we've done, okay, right? When we set the input equal to 3 and the output becomes 0, what am I describing? Maybe this will help. So let's check this out. So check out the side screen here, y'all. And if I were to enter in, right, I'm going to put y instead of f of x. So if I were to put y, let me switch here. Give me a little bit more room here. Right, if I put y equals that same thing we just did, x minus 3 times x plus 2. Check it out. Look at that, where that x is negative 2, y is, or f of x is 0. And when I input 3, right, my output is 0. So essentially, going back to this screen here for a second, y'all, these are, you got it, my x-intercepts. So that red function, going back to that, and I'll describe that, this function that you see here, this red function, this is, right, remember x minus 3 times x plus 2 is a factored trinomial. This is a trinomial. This is that trinomial. And like we talked about before, anything that has like an exponent, right, when you see an x squared, right, it's not going to be a nice line, right? When you do x plus 3, right, if I do that here, x plus 3, right, that's a line. But anytime, remember this is still factored, anytime you enter in something like this, or essentially with an x squared, it turns it into a curve. And so going back here, right, I want us to know that these are x-intercepts. So even if, right, friends, I was to put in, let's say we did another one. And now you know the factor forms of all of this. So let's say I had something that looked like this. And I said, I want to know the x-intercepts, or I want to know what are the values of x that would make to satisfy this to make it 0. And let's say it was this. Actually, I'm not even going to make it that close. If we were to factor this, right, what would you get? Tell me what you got. Factors of 30 that work, 5 and 6. I got 5 here. I'm going to put a 6 here because that's a plus. I'm going to put a plus here. I'm going to put a minus here, which means my x-intercepts, or my x values that satisfy this to make this 0, right? Satisfy this to make this 0, that f of x equals 0. I'll put that over here. You'll get 5 and negative 6. Now, on Desmos, right, because you can use Desmos.com, because that's essentially what I'm using. You could input, right, you could type in the x squared plus x minus 30 and still get the same answer. But I'm going to put in the factored version just so you can see it. I'm going to get my x plus 6 here. Remember, Desmos.com, you don't need a login. You can literally just go to Desmos.com and go to the graph calculator, and you can totally see this for yourself. Now, I'm going to zoom out here just so we can see that, right? This is a huge graph. And if I zero in and I get to the negative 6, I should see a 0. And if I go over to the 5, I should see a 0. So now you understand just a little bit more that these trinomials can be used to describe all types of things. The growth and decline of business and profits, it can do all of that, right? And it can show us exactly what it takes to either break even, right? Or to like, here's an even point and then we get into increase. So we use a lot of trinomials. We use a lot of graphs to help us interpret all types of things: population growth, infection rates, birth rates, success rates, even in classrooms or on testing or anything like that. Okay, so we're starting to get into how this can be applied in really real world situations. Okay, so I wanted you, the big thing that I wanted you to get out of this short video was understanding now that yes, I've been having you solve for the x values when you set it equal to 0, and what you are solving for, right, are x-intercepts as they pertain to a graph. All right, so that's it. Give it a shot. Give that classwork 10 a shot. As always, I'm here if you need me. And yeah, let's just continue to keep going forth unafraid, y'all. You got it.